Um, my name is Rohit Mittal. I'm a principal product manager in Amazon Bedrock team. And today we are going to talk about a very interesting topic. It's called Explore Image Generation and Image Search using foundation models on Amazon Bedrock. I'll be joined with two of the other speakers, Ashwin Swaminathan, who is a senior manager of applied science in Amazon AI team, and also Andres Velez, who is a principal data scientist at OfferUp. So images are a very interesting form of expression. They are able to grab our attention immediately. And our brain can process an image in less than 100 milliseconds. In the world of AI, one of the most captivating things that have recently happened is in the form of visual art. Now, using just some text prompts, you can easily generate compelling images. You can have your creativity go wild. We have already seen that we have sent astronauts on horses in the galaxy. We have created visually striking unicorns, or even put a sailboat inside a light bulb like here. So the amount of visual content that is available right now and that is being generated at the moment is skyrocketing. With smartphones especially, people take more than 5 billion images per day, which is more than 1.8 trillion images taken per day. That's an enormous amount, right? So think about searching of these images for any business application, or searching through a product catalog on a retail website, or even going through your past memories to look for the image that you spent with your family a few years ago. It's getting challenging and challenging every day. With the image generation tools, on the other hand, things have exploded. In the last year itself, people have generated more than 15 billion images using these tools. And the trend is going exponential in this. So we have a big problem of the content being generated at a massive scale, and we do not have the right tools using the traditional machine learning and the keyword-based searching tools, where you can easily search through these content on your devices or for your business needs, right? Now, generative AI has come to the rescue here as well in terms of searching of these contents, and also to generate the compelling images by improving the efficiency of content creation. So in today's session, we will see how Amazon Bedrock is solving both these problems of helping you to create compelling images through the image generation model, and also through our embeddings model to search through the existing set of images. So in the agenda today, we'll go over the two new Titan models that were launched yesterday in Swami's keynote. The first of them is Titan Multimodal Embeddings. The second one is the Titan Image Generator, which also does the image editing tasks. Then we'll look at some of the example use cases and architecture, all of them using the Amazon Bedrock service, which is our foundation model as a service. And then Andres will walk us through how search is relevant for OfferUp, helping local buyers and sellers come together on their platform, and also how these Titan models will help achieve their mission. So a quick primer on Amazon Bedrock, right? So Amazon Bedrock is a fully managed service that provides access and choice of some of the best of the breed foundation models from leading companies such as AI21, Anthropic, Cohere, Meta, Stability AI, and also our Amazon Titan family of models, which are built from scratch at Amazon. Now, until 2 days ago, Amazon Titan models were primarily text-focused. You were able to generate text using the two texts, the Titan Text Lite and Titan Text Express models, and also the Titan Text Embeddings, which is similar to the multimodal embeddings, but for the text search and text similarity type of use cases. Now, Bedrock not only provides a choice of these models, but also provides a lot of capabilities that helps you build the entire Gen AI-based applications for your use cases, and also doing it in a very private and secure manner. So let's get down to what we launched yesterday. So these two new models, the Titan Multimodal Embeddings and Image Generator, are again built entirely from scratch. The first one, the Titan Multimodal Embeddings, it takes text and image, or a combination of both of them, to represent them in a set of vectors, a numerical representation which we call embeddings. And the main idea behind that is you can capture the semantic meaning of the input, whether it's the text or the image or the combination, in the form of vectors, which makes it very easy to search on them in a very fast manner. And also, as compared to the traditional form of searching using keywords, where you tag the images with a set of keywords in a manual or an automated way, and then looking at the input query keywords and trying to match them, it doesn't give you the right set of accuracy, plus it's not resource efficient as well. So this model helps you with use cases such as search, recommendations, personalization, especially if you have just the images, for example, stock photography companies that have hundreds of millions of images. Their primary business is search, where end users try to discover the unique content to buy, right? And especially for the content creators themselves, where the discoverability is a major problem, right? So this model helps you with all of that by providing the state-of-the-art. So this is a state-of-the-art model, which provides the best-in-class accuracy in terms of the embeddings that are generated, so that you can build search and recommendations type of applications on top of that. The second model is the Titan Image Generator one. Again, what we have focused here is reducing the time it takes for you to create the content, especially for industries such as advertising and marketing, where they have products and they want to generate compelling lifestyle images for them so that their customers can see the benefit, click through on that, and it results in the more audience and more eyeballs and more revenue for them, right? Now, both of these models have high accuracy out of the box, right? So you can use the base models, get very accurate results. What we also differentiate on is providing the customization feature through Bedrock API, which is a simple API to just customize these models on your proprietary data. As with any AWS service, all your data is highly secure and private. So whatever inference calls you make is not stored on the Bedrock, right, on AWS. It's not shared with any of the third party. But in the case of Titan also, we do not use any of the data that you use to customize these models to train our models to make them better. Everything is very secure and private, including the customized model, which is, we create a secure copy of the customized model for you. So not only we provide a way to easily customize based on your data. Think of it as, again, I'll take an example of the advertising industry, where, I mean, every brand has a particular style, particular brand aesthetics in which they create these images, the ad imagery. So you can train the model on only 100 or a few thousand pairs of images, bring it to the Bedrock API, create a customized copy of your model, and then the model will reflect your brand aesthetics in the images it generates. We also provide a comprehensive set of features with our image generation model. So not only text to image, but in painting, out painting, and we differ in the case of out painting, where, again, focusing on the advertising and marketing use cases, or even e-commerce. If you are a seller, you can bring in your product image. You can easily create it, such as couch. I mean, it's a different thing of a couch with a plain background versus in a homely setting in a living room with a fireplace. So it creates more warmth. So the idea is you can create very lifestyle images very easily using a simple API with very low distortions, high accuracy using this model. And we have another set of features that we'll dive deep into in a few minutes. Now, one of the other things that is very important for us at Amazon, and we have done that with every Titan model, is the responsible use of AI. And to continue supporting the best practices in the responsible use of AI, all the Titan FMs are built to detect and remove harmful content from the training data, reject inappropriate prompts from the user at the inference time, and also remove any harmful content that the model might generate. So again, you do not have to worry about implementing additional responsible AI guardrails on top of the model output. And that is especially important with image generation kind of models, where you can imagine, given how powerful this medium is, I mean, we do not want to generate things that can be sensitive to certain people or toxic in any way, or even biased, right? We see a lot of biases in our world. What we are trying to do with these models is we help to mitigate those biases around gender and skin tone and other stereotypes. So going to the first model, the Amazon Titan multimodal embeddings model, this is now generally available. So as I was mentioning before, traditionally, a lot of content owners used to create tags for the images, right? And then try to match the input query keywords to those tags. Similarly, in the case of retail industry, you may have a lot of product images you want to sell, or you want to search for them. But in a lot of cases, the description is either missing, or inadequate, or inaccurate, right? And I'll show you an example in a minute. But all of that leads to is the discoverability problem. So at the end of the day, end users are not able to discover the right content that a seller wants to sell, right? So it's not a good experience for either the seller or the buyer or the platform itself. So what the embeddings do is capture the semantic meaning from the images. I'll show you this example. Now, on the left-hand side of this image, what you see is the result for the query blue sneakers without laces using just the text-based searching, just based on the product description, whatever, and using the keywords. And things like without, like negation type of things are particularly harder, right? On the right-hand side, which is highlighted, as you can imagine, that's the result of our multimodal embeddings model. Because the images themselves capture the information of the color, that there are no laces, so the information that is represented in the embeddings capture the meaning from the images. And then when the user searches for these keywords, they are mapped into the same semantic space. So we are able to correlate the input query to this set of images of the right shoes that customer was looking for. So it's a great user experience for the end user. It's a great experience for the sellers because their right items are being surfaced, and for the platform itself, the retail platform itself, so that customers are happy, they'll come back, right? Now, there are three main benefits of these models, of this model specifically. The first one is accuracy. The second one is ease of use. And the third one is responsible AI. So let's dive deep into each one of them. Now, the accuracy. So as I said before, this model is state-of-the-art in terms of how accurate search and recommendations you can build out of it, out of the base model itself. We also provide some mechanisms for customers to further improve that accuracy, especially if you have some data which is unique to your domain, such as autonomous vehicles. They capture billions of images of a particular type, right? I mean, they could be wide-angled, wide-lens images, right? So you can further improve the accuracy of the embeddings by, again, providing a few hundred or a few thousand images of your type, and then the accuracy will be better. Again, it's all securely customized, privately customized to you in terms of the data and the model itself. We also provide another lever to the customers. Now, the default embedding size that we generate is 1,024, which is based on our talking to hundreds of customers, analyzing the right accuracy and the latency. We believe that is the right embedding size for majority of the customers. But as with Bedrock, we want to provide the choice in front of the customers. So we also provide you the option to generate smaller size embeddings, 384 and 256, so that based on your needs, if you want to optimize further for latency, you can go down in terms of the embedding size, right? So we provide that option to the customers. Let's move on. So the second one is the ease of use. Now, the whole Bedrock premise is also around ease of use. And this is also reflected in our Titan multimodal embeddings. So we have a single API to generate the embeddings. We have a batch API so that you can input, say, thousands of your images to generate embeddings. We also have OpenSearch connectivity. So if your content is already on Amazon OpenSearch service, or if you are exploring something which provides a more integrated and seamless experience with using the embeddings as well as indexing your content, you can use Amazon OpenSearch service that has a connector to Bedrock. So you can directly generate the embeddings through this model from OpenSearch and store it in the vector DB that Amazon OpenSearch provides. So you don't have to leave anywhere. The third benefit is the responsible AI. Now, we filter harmful content from the training data for this model, and we help to mitigate the demographic biases, especially if you have a lot of images containing people, and you don't want to have the search results that only represent a specific skin tone or a gender or other types of stereotype biases that we see in the real world. Then we have a patent-pending technology that helps you minimize or mitigate all of that. So that's another benefit or a differentiator that none of the other embeddings models will provide to you. Now let's look at the second model, the Titan image generator, which is now in preview. Now, it provides a lot of features. Text to image is the main one. The way we differentiate from our competitors, and you have seen, I'm sure you have seen a lot of models in this space already, right? But we have a lot of differentiators in this space. We want to go through them in terms of features as well as in terms of the benefits that we offer. Now, text to image, we generate high-quality images out of the text prompts. The way to analyze how good a model is not just in the output, but also how easily you can generate those images, right? You should not have to craft very lengthy or very detailed prompts. So our idea here is simplicity. So you can simplify your prompts, have simple prompts to generate compelling images. The images have low distortions, right? So, or you can call it hallucinations as well. What we also do is generate text in the images. So if you want to say, I want to generate a greeting card that says something, say, Happy Thanksgiving or something, right? We'll have an example to show. You can easily do that, right? It understands complex prompts as well. So this is different from the simplicity that I mentioned, right? In simplicity, if you have something in mind, you should be able to easily define that. But in certain cases, you want to say, OK, I want this object to be placed there, and then doing something. So where it's basically a 2 or 3 step process, we can easily understand those complex prompts and generate accurate images. I'm going to show some more examples there. Then in terms of customization, the last one, As I said before, customization is a key thing that majority of our customers are looking for. Because every company has their own proprietary or unique data, their brand aesthetics that they want to convey in the model, right? While the base model will do a decent job, but it can't know what is proprietary to you, right? So you can, again, easily, with only a few hundred or thousand images, you can easily do that, easily customize. In terms of image editing, we provide in-painting, where you can replace an existing object by another one, or remove an object, traditional in-painting. We have automatic editing, which is very powerful, driven by our own model that you'll hear more from Ashwin about. But what it does is you input an image, and you just enter a text prompt of what modifications you want to make to it. And it'll understand your intent, as well as what specific object in the image you're talking about, and do the modification for you. You can also do the same thing with using an image mask, if you want, right? Definitely, it will provide more accuracy if you have a specific mask. But then, so you can do either the mask-based editing or the mask-free editing, which we call automatic editing. We have generative resizing, which you may be very familiar with in terms of DALL-E or other models, where you extend the image boundaries, and it can be guided with a text prompt as well. So you can say that, OK, I want to generate an image on the left side. By default, it will try to keep the elements that are in the original image. But you can also guide it that add something on this left-hand side, and it will try to do that. Our outpainting is specifically aimed for advertising and marketing use cases, where you bring in a product image, such as a perfume bottle, right? And you want to showcase in lifestyle setting, like I was telling before. So you can very easily do that with this feature. With some of the other traditional models, you'll have to go through a few steps in order to generate that. And then it adds hallucinations or distortions to the input product image. So here, we are focusing on very less distortions, plus ease of use in terms of generating what you're looking for. And image variations, where you can have an input image, and we can generate similar-looking images based on that. So let's look at some examples here. Now, this is a very interesting use case because, as you know, wine glass and elephant are not similar size. So it's a very complex thing to have them scale to the right size and then reflect that in this composition of different objects. Now, we have tried all of these examples with the competitor models. And I mean, you can try them yourself and see the difference. Tiger wearing a fedora. Now, this is very interesting. So if you read the prompt here, it has 3 parts. First, it's a dog wearing a suit and a tie, right? So first you generate that. And then you have to make sure that it is printed on a pillow with the right aspect ratio and size, et cetera. And then the pillow is also on display with other furniture. So it's a very complex prompt. And as you can see in the quality of the image, it gets it right. This one is again, one of my favorites, which not only shows the complexity of the prompt, again, a person wearing a hat and dark glasses, running in a forest, and then the properties of the forest itself, which is lush green with red and yellow flowers, right? Another thing to point out here is the diversity. As I said before, responsible AI is very important for us. And we ensure that gender, skin tone, all of that is reflected as it reflects in the real world. So another example, again, I tried this with some of the competitors. Either both the boy and the girl were wearing the hat, or none of them were wearing the hat, or the kimono was not right. So, or both boys or both girls were generated. But again, a very complex prompts where you're defining that the boy is wearing the hat and standing next to a girl wearing a kimono, right? This is an example of how it can also generate artistic images. This is an example where I wanted to show you how in the images you can also generate text. So the prompt is image of fireworks with New York City. Suppose, we have some customers who want to enable their end users to generate these kind of greeting cards and things that they can share on holidays or events. So they can accurately generate such images. As you know by now, if you heard Swami's keynote yesterday, we love iguanas here. So we have a photo of iguana in a colorful background. So these were all the text-to-image examples before, where we showed how not only the quality is good, but how we understand the complexity of the prompts and still able to generate the right images for you. Now, taking the iguana further, as we can see here, suppose you are a children's book company, you want to automatically generate images of a particular style, say a cartoon or a sketch, right? And suppose the model cannot understand that. It will, but suppose it does not. Then you can, again, bring in some of the examples to the model, train it, and then the model will be able to generate the customized images based on what your use cases are. An example of automatic editing, where you start with an input image, which is actually generated one by our model. And then you define a prompt, change flowers to orange color. We understand what you're talking about, where the flowers are, and we update that. In painting, again, we start with the left-hand image, which is also generated by our model. A barn with a lush green forest with mountains behind it, lake in front of it. You can add a car in front of it, right? Now, in the next step, you can take one of the generated images, which is now the left image, and you want to change the mountains. So, you can adjust that. You can add some ducks on the lake as well. An example of the outpainting, like I was showing before, a product which you can bring in, and then you can generate in any lifestyle background you want. Image variations. Again, this is an example that Swami also showed yesterday. But from the reference image, it can generate similar-looking images. We also want to show you here our new image playground that is on the Bedrock console, with rich features where you can either generate or edit images. You can provide negative prompts as well. You can select a style. You can select a size, the number of images between 1 and 5 that you want to generate, the seed, and and you can get the results directly. With that, I'll hand over to Ashwin to walk you through the benefits of this model, as well as the use cases and architecture for this model.
Thanks, Rohit. So as Rohit was mentioning, as we were building the image generator models, we started with 3 basic principles, and we wanted to make sure that we do that really well. So one is we want to provide images with very high accuracy and high quality. So it's very easy for you as customers to be able to use our models. Second, we want to make it very easy for you to use in terms of building the right APIs, right tools, so that it's easy for you to integrate the models into your own applications. And finally, we consider responsible AI front and center, so that we can, as our models, you feel comfortable using our models, and the models provide the right kind of data and right diverse kind of data, non-toxic information, so that you can integrate it with your applications directly. Let's talk a little bit more about each of these categories. So we do, as you have seen in some of the images that we just showed, we try to ensure that the quality of images that we get from our models are very good. So as part of that, we did extensive evaluation studies over a wide range of prompts, looking into all the different categories of things that customers would be looking at using. So categories such as composition, where you're looking at placing objects relative to each other in the scene. Or complex prompts. You saw some examples of complex prompts in the ones that Rohit showed, where you had a person running through a forest, wearing a hat, wearing dark glasses, and the forest had its own properties. So we want to make sure that our models, as we generate them, are very good in terms of being able to use for these kind of use cases. And we also want to ensure that it understands these things and it can support text generation. So if you want to be able to use it for generating birthday cards, greeting cards, or signs, road signs, you will be able to use our models, put the text in the right places so that you can use it and directly integrate with your applications. In terms of building the applications itself, just like everything in Bedrock, we try to ensure that we have the right tools, right APIs, and we are able to use, and customers, you guys, are able to call the APIs to generate the applications itself. So we provide a simple API for image generation. So it takes a text prompt as an input, generates an image, and you have the option, as you are seeing in the playground, you have the option to say different resolution images. We support around 8 to 10 different kind of resolution, all the way from a 512 by 512 resolution to a 1024 by 1024 resolution. You're also able to play with different seeds. You can try different kinds of images, generate multiple number of images at the same time. So we provide all that as part of the API definition itself. So you can integrate it directly with your application and expose and use it as part of your workflows. And one of the important things that we did is also looking at each of these features that we launched to understand how can we make it easier for you guys as customers to be able to use it. So taking in-painting as an example. So we have, we saw an image of a lush green forest, and you saw a car in the lush green forest. So let's say I want to replace a car with a truck. So a traditional workflow would be to go into the image, take a mask, take your mouse pointer, mask out the regions of the car in the image, and use a text prompt to say, okay, replace this part with a truck. And we do support those use cases for people who want to be able to use it with those kind of mask outputs. In addition to that, we also provide an automatic editing feature where you don't have to go in and update the mask. You can use a text prompt and say, okay, replace a car with a truck. And we built our own in-house segmentation model, which understands the world knowledge, which understands objects in the image, and is able to identify the pixels in the image which corresponds to a car. Go in and create a mask automatically for you, and then you can, it will call the in-painting model to edit the mask to generate the output in terms of generating a truck in that place. So we looked at how can we make it easier and simplify your workflows so that you can generate large quantities of data easily with our model. We have an API also for generating image variations. So you generated an image of a truck in the mountain. You want to generate different variations of a truck. You want to be able to generate different styles of the same photography. How to be able to generate it in a way that it makes it easier for you as customers. So that's something that we also looked at, and we have a separate API for generating image variations. And finally, we also wanted to see what more can we do from a basic core model itself. So we provide the fine-tuning capability. As customers, you can bring in your own data sets. We will train our model specifically fine-tune the model specifically on our data set, provide a model to you, which only you will have access to. And the data is not going to be used for any of the other training that we use for our own model creation. So this model is separately hosted for you. You have full access to the model, and you can call the model to run any of the applications that you want to be able to run for your own applications. So as part of the fine-tuning workflow, the traditional way to do fine-tuning is you bring in an image, you bring in a text pair, you have an image text pair, pass it as an input to the API. It can be in an S3 container, and you point a link to the S3 container to the API. And we use the image and text pairs to be able to train our model. And one of the things that we also looked at is how do we simplify this workflow? And in this case, we said, okay, if the customer doesn't have to bring in the text and only provide the images, can we make it easier? So as one of the things that we'll be launching soon enough, We have our own captioning model where we will caption the images for you and use that for generating the image text pairs for fine-tuning the model. So as every step of these use cases, we try to look at how can we make it easier for you as customers to be able to use our model and try to incorporate that in your workflows so that the overall ease and our overall work process becomes as simple as possible. And thirdly, like I said, we also made sure that our models are friendly from responsible AI standpoint. We do wide range of mitigations throughout our model development process. So we take responsible AI ground up from day one to see how do we make sure that the models that we generate, the images that we generate are safe. And you as customers would be happy to use our models without worrying about generating not safe for work content or toxic content and things like that. So we did extensive filtering on the data side to improve our model creation process. So that data that goes into the model is good and clean. We also have guardrails as part of our system and proactive filters as part of our system to ensure that the text prompts that you pass in are checked and verified that it's not going to generate toxic content. At the same time, the image content that the model creates or generates is also set up in a way that it goes through filters to make sure it does not generate not safe for work content or violent content as part of the image generation process. As Swami mentioned in the keynote as well yesterday, we ensure that our models are also watermarked. So you have an authenticity trace. So any image generated by the Titan image generator model has an invisible watermark that goes within the image. So very soon we'll have an API where you can call the API with the image, and we will verify for you that the image was created with a Titan image generator. So this way we ensure that the images generated are safe. We ensure that there is authenticity proof. And we check that it does not create deepfakes around in this environment. And the last part of it is also about demographic bias. And you would have seen a lot of this in a lot of the text-to-image models that has been already out there. So let's take some examples. So if you have an image of a couple posing together, most traditional models are tailored based on the data set that it was trained on. And there is generally some bias in the data set. So the data set could be biased to a certain category of people, or a particular skin tone of people, or ethnicity of people, or certain geographical locations where the people come from. And as part of the whole training process, we also ensure that our models can see diverse amount of data of all different skin tones and genders, so that as we are building these models can represent the wide range of people. Another popular bias is when you have high quality, an image like this where you're looking for a lawyer, there is an inherent bias in terms of the kind of lawyers that you find in certain demographic areas. It could be a particular color, a particular gender, but we make sure that the models that we generate cover a wide range of possibilities. That way, you as customers can use our models to generate these variations and different kinds of people and be comfortable about using them in your own applications. So as part of it, we also build a patent pending technology where we specifically look at how do we take the image information and the embeddings information and have them in an unbiased space so that we can use this data to provide all these diverse kind of outputs that you see in these images. And all that is integrated as part of the Titan image generator. Now let's walk through some example use cases on how you can use our models. Let's say you want to build a multimodal search experience. So you have a set of images and text pairs. The first step is to do the indexing. So you will call our multimodal embeddings model. You will index the model you'll call our, and generate embeddings. As Rohit mentioned, we provide the option for you as customers to have different embedding lengths. So for customers who want high latency or very low latency, we provide a smaller length embedding of 256 length. And you can use those embeddings to generate those faster searches. For customers who want very high accuracy in your searches, you can use a 1024 length embedding. Index your own image database using the 1024 length embeddings, and use that for generating the image database. So we did also make sure that it's easy for, in terms of database integration. We have a whole vector DB store. We have integrated with OpenSearch, so it makes it very easy for you as customers to be able to call OpenSearch APIs. You can call our Titan embeddings model from OpenSearch, and that way the whole system is integrated if you're a part of the whole Amazon ecosystem. We also have integration with Pinecone. So you have a wide range of options to choose from depending upon your use case and your needs, so that you can use the power of the embeddings model, the power of the foundational models as part of the embeddings, and at the same time be able to support your use cases, be it use cases which require higher latency or be it use cases that require higher accuracy. As part of the embeddings model, again, we do ensure that the embeddings are also defined in a more responsible manner. So if you have if you have a database of images, say a database of CEOs, and and if you have different kinds of gender and different kinds of skin tone as part of the database, we do ensure that the embeddings that you're generating cover all these things in a very fair manner, so that when a person puts in a query, you're able to retrieve the corresponding images regardless of gender and skin tone. So then let's talk through the querying workflow. So in a querying workflow, you would go through the same process. You have a text. You can search through the database using text prompts. You can search through the database using images to find similarity searches. Or you can also search through the database using a combination of text and images. So let's say I want to be able, for retail kind of use cases, I want to be able to retrieve an image of a green shirt, but I want it in a different checker pattern. Or I want it to be able to do it in a different color. So you can think of complex searches which has images and text as queries, and we can support those kind of queries. So I want to be able to find an image which is of a particular style but a different color, and I can add an image to the search query, and I can use these kind of complex search queries, and we support those as well. And then you would call you call the multimodal embeddings model. We'll generate the embeddings, and then you can use it for retrieval applications. Let's go through one more example of a text-to-image model. In the text-to-image model, you start with the input text prompt. You call the Bedrock API, and it will generate an image. It's as simple as that, so it makes it very easy as customers for you to be able to use it. And for image editing, you can have a combination of it. You can have an input image along with a mask. So we do have the option for customers who want to use masks. So you can have an input image along with a mask, and we can do editing, in-painting, out-painting with those masks. Or we can do it with a text prompt, like we described. So in that case, we would generate the mask, and we would run in-painting and out-painting with those masks. Let's take an example of an ad creation process. So here you have a database of perfume bottles. You want to be able to create an ad copy from this database. So as a first step, you want to retrieve a good image of a perfume bottle that you want to create the ad with. So you would start out and say, okay, I want to be able to retrieve the top 5, top 10 search results from my database. As a next step, you want to be able to generate a very nice looking image of the perfume bottle, which you can integrate it with your whole ad copy workflow. So there you can use our image generation models to be able to do that. And then you can use image variations to create different variations. Okay, I want to be able to have a perfume bottle in a different style. Or I want to have a background in a different style. You can use the image variations to be able to do that. And finally, you can use text models, and we have a wide range of text models as part of the Bedrock suite, where you can use one of the text models to generate the whole test description, which you can pose as part of it. So with a combination of all the different kinds of models that we have in the Bedrock family of models, you'll be able to go through this whole workflow. So you can use the Titan multimodal embeddings model to search through a database, find the set of images which have a perfume bottle. You can use a Titan image generator to generate variations, to add backgrounds, add different kind of sceneries to it. And finally, you can also use the Titan text model and the Bedrock text models to do text generation for ad copy. Let's walk through a quick example. So the first step would be to create a database. So you have a database of all perfume bottles, all products that you have as part of your whole workflow. You would use a Titan embeddings model, a multimodal embeddings model to index the database, create the reverse index, and then given a search query like a perfume bottle, you would search through the database, find the most relevant information from the database so that you have a list of all perfume bottles that you can look through. As a next step, you would call the image editing API. As an image editing API, you can use automatic masks, in painting. You can outpaint it with a different backgrounds. You can stylize and look at how do I create the perfume bottle in a beach environment, or in a forest, or a cityscape environment. We can create different kind of backgrounds, play with it, and ensure that you have a good-looking image that you can use for your product use case. And finally, you can generate different variations of it, where you can say, okay, I want to be able to look at different styles, different kind of backgrounds, so that it becomes a very interesting, catchy image that the customer can look at. And finally, use the image text generation model. So here you would take the text, call the text API, a Bedrock LLM text API, along with things like the search keywords or product descriptions or image backgrounds. And use all this information together. The LLM will create a good-looking text description. You can attach it with the ad copy and then create the whole version. So this way, we try to make sure that as part of the Bedrock family of models, the Titan image generator, the Titan multimodal embeddings, and the whole LLM suite that we have hosted in Bedrock, it makes it very easy for the whole use case workflow to come together so that you have one-stop place for running these kind of experiments and creating these kind of workflows. So with that, I'll hand it over to Andres. Andres will talk about how they are using it for the OfferUp applications.
Good morning to everyone. My name is Andres Velez. I'm a principal data scientist at OfferUp. I'm here to talk pretty much about how OfferUp builds transformative experiences using search with Amazon Bedrock. But for those, I'm curious, raise your hand if you have used OfferUp before. Awesome, nice. For those who actually don't know about OfferUp, it was founded in 2011. And nowadays is one of the pretty much the largest mobile marketplaces for local buyers and sellers in the US. One interesting fact is 1 in 5 people in the US use OfferUp nowadays. And we have transformed how local communities buy and sell products, and by providing an application in which is unique, simple, and trusted for come up with these transactions. Our mission pretty much is to be the platform of choice for local commerce by connecting buyers and sellers through an interface that makes selling an item as easy as snapping a picture from a mobile device. And we are here pretty much to talk about search, right? So search in general is a really important piece in any application. And this is because by tweaking the search, investing in search, you are able to just like leverage multiple application metrics. So let's imagine this scenario. A user goes to the application, search for a product, then, and if the product is personalized, then it is going to save time and effort looking for what they need. Then this is going to, if this process is optimized, then the user finds what he needs and is going to try the steps up. Otherwise, you have insights to improve the platform, to go back and forth and keep improving. After you apply these changes, then they are going to materialize in the user experience, right? Which at the end is user retention metrics, which are going to be increased. There are multiple types of search engines, and mobile search has its own challenges. The first one is broad and short search query types. Users tend to use approximately between 1 and 5 key search terms. And this is really complex because you give short context to actually look for what you want. If you look for other search types, engines, you actually generate more description. You generate more context for your search query. And the other aspect which is challenging is the variation in the quality of the user provide content. And if you look at the image provided here, it's they are really good quality. They are awesome. However, some users, they provide low quality images, and this is challenging. And if you look to the title and description, some of them are really scarce. They don't just provide so much context to the product. And another I can think of is the limited screen real estate, making good ranking crucial to succeed in the application. And these are pretty much some complexities in mobile marketplace search. And this is an evolving area. And we at Opera, we are working really hard to keep up with the latest changes. And we have begun with that journey, which began with keyword search. And we use keyword search all around the application. This technology has pros and cons, right? And pretty much we use the keywords that the user provide and match it in the engine, right? We retrieve those listings which actually match it. And on top of this technology, we explore neural search. So we start using vector databases. We start exploring OpenSearch. And also, we use Amazon SageMaker to deploy our models, building house for semantic search. So we took title and description and generated the embeddings, and then we stored these embeddings, we index them in the vector database. Before going to production, we test this new stack of technology in 2 main aspects. The first one is latency. We want to just be compliant with the SLAs we have in the company. And the second point is quality. We want to make sure the retrieved listings just actually come out with good results. For this, for the latency, we pretty much perform experimentation. We backfill OpenSearch database to millions of listings. And after we backfill this information, we apply RPAs to 100 of our RPAs in the database. For all the scenarios, we see approximately under 60 milliseconds for P99, and this is awesome. We are really surprised, and we are really happy to collaborate with the OpenSearch team at Amazon because it has a great community support. The other experimentation we did is quality. And for the quality assessment, we retrieve items using the top 25 most used keyword search in the application. And with this information, we retrieve certain amount of listings, and we compute the relevance recall. For the relevance recall, we have as baseline, the keyword search. And if we look at the results, there is approximately a 23% increase in the relevance recall by using semantic search for the low-density locations, and a 27% increase in relevance recall for the high-density locations. High-density locations is number of products per area, and that's a really improvement switching to this technology. But if you look at this, there are great numbers, right? But there is a missing piece in all these aspects. And if we look at this image is, first of all, it's a really nice deal. I will definitely buy this for my house. And if you look to it, the title is pretty much not really meaningful. And the description is really short, right? But if you look at the image, right, the image gives you a lot of details such as the color, the shape, the number of seats it's being sold, and also the size of the seats. So the image just gives you a lot of more information about this context. And that's why it is really important to take this into consideration. So for this, we are using Amazon Titan multimodal model. And we pretty much integrate this new component, right, in our journey. And we pretty much take the image alongside the title and description. We pass it through the Titan multimodal embedding, and then we index the vector database with this information, which is enables us to search with these new components. Let's imagine this, without this multimodal model approach, we don't make certain listings discoverable. So this is really important. And also from the technical point of view, the partnership with AWS, Amazon, has allowed us to test new technology in really short amount of time. So that will take us to a couple months to build this new technology. And we also test that in terms of quality, following the same methodology I explained before. And with the Titan multimodal embedding model, it has demonstrated an improvement for low-density locations, approximately 9%. And also, it has reduced the variance for both low and high-density locations. This is really, really nice, because at the moment, we haven't applied any transfer learning on it. So it's the way as it is. And if you look at the reduction in variance, it actually makes the system more stable. In general, this journey, to summarize, we began with keyword search, right? And then we started exploring neural search with semantic search. And this yielded 23% for low-density locations, and 27% increase in relevant recall for high-density locations. So it has been a great improvement. And then, on top of that, we started exploring new technologies. We started exploring a multimodal embedding technology, which at the same increased the relevant recall for the low-density locations, like maintaining the same performance for the high-density locations without applying any transfer learning on it, and make the system more stable. So you are thinking, what is next? Pretty much, we are researching how we can further leverage AI tools to support search, recommendation, image generation, and more within OfferUp. Thank you.
Thank you, Andres. So as a summary, we learned about the Titan image generator model, its capabilities, its differentiators, benefits, et cetera. We learned about the Titan multimodal embeddings model, again, the differentiators and the benefits, et cetera, as well. And the next step with OfferUp and other customers such as you, I hope you got some idea of how beneficial it could be for your use cases. So we are really excited to work with you and see how these models can help you benefit to build your GenAI applications. So thank you so much.